Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners. Welcome back. Welcome back to our Term 3 live lessons. Today, we're going to do forces under the strength, energy, and change. Your presenter is Sianda Madlala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right. Remember, I said that we're going to do forces, and we're going to specifically look at types of forces and contact forces. I hope we are ready to learn. So now, let's look at the lesson objectives. By the end of this lesson, you should be able to define what a force is. So you should be in a position where you can tell us what a force is or what does force mean, right? Second, you should be able to identify the unit of measurement for force, right? You should be in a position where you can tell us what is the unit of measurement of force. Thirdly, you should be able to describe contact forces. You should be able to describe contact forces for us. Then you should also be able to discuss examples of contact forces. That's all that you need to focus on for today. Simply defining force, identifying the unit of measurement for force, describing contact forces, and also discussing what? Examples of contact forces. And all this information, you find it under the CAPS document on page 71. So now I hope you're ready for learning. Let's look at what we have done before in the previous grades and the same grade prior to this lesson, right? So now, we also have done in grade 5 energy and movement. We have done energy and movement in grade 5. And also we have done in grade 7 gravitational force, right? We have introduced gravitational force in our grade 7 as part of our lessons. Also, we have done what? We have done atoms, right? And we have done chemical reactions. And we said that in grade 8, a bond is a force that holds atoms together. We also have done in grade 8 particles of matter, right? We said that particles in gases have weak forces between them. So I hope you still remember some of these topics, right? So now, let's look at this baseline activity. I want us to use this baseline activity to test our knowledge so far, right? To test what we know and don't know so far. Let's go through the questions together. Number one. Number one says, what is a force? Right? What is a force? So you simply need to define force for number one. Number two, what is another name given for non-contact forces? Or what is another name for non-contact forces? You simply need to write down the name. Then number three, what are the two main types of forces? We want the two main types of forces. You simply write them down, right? Then number four, what is the difference between a contact force and a non-contact force? For all these questions, I'm going to give you 5 minutes. Then after 5 minutes, we can meet again to answer these questions. Welcome back, grade 9 learners. Now, I hope you were able to answer our questions, right? For number 1, what is a force? Number 2, what is another name for non-contact forces? Number 3, what are the two main types of forces? And number 4, what is the difference between a contact force and a non-contact force? So now remember, before we continue, right? If you want to WhatsApp us, we have our WhatsApp interactive number, which is 079 578 2908. You are free to contact us on that number should you have any questions or any comments, right? So now let's look at the solutions. Number 1, what is a force, right? What is a force? And we define a force as what? We define a force as an action that can be described as a push or a pull. So a force is an action of pulling or pushing, right? Then you mark yourself. Then number 2, what is another name given for the name non-contact forces? What is another name for non-contact forces? And those are what? Those are field forces, right? Number 3, what are the two main types of forces? We just need two main types of forces. And those are your contact forces and your non-contact forces, right? Then you mark your work. Then lastly, what is the difference between a contact force and a non-contact force? The differences are that a contact force is the force that needs the two objects to touch each other for the force to act, right? A contact force needs two objects to touch each other for the force to act. Whereas a non-contact force, they act over a distance without touching each other, right? They can act over a distance. So now, let's just take good 2 minutes so that we're able to copy down the corrections. Welcome back, grade 9 learners. Now remember, if you want to ask any questions or you have any comments on this lesson, just send us a WhatsApp on 079 578 2908. We'll be glad to answer to all your questions and your comments. Now, moving forward, let's look at the terminology that is involved in this lesson. The first term there is force. Now, what is a force? A force is an action that can be described as a push or a pull, right? So when you are pushing something, when you are pulling something, you are applying what? You are applying force. So we can clearly say that a force is an action that can be described as a push or a pull. Secondly, we have Newton. what is this Newton? And a Newton is a unit of measurement for force. It is a unit of measurement of force, and it is abbreviated as N, right? When calculating for force, we find that the answer is what? Is in the units newtons. Thirdly, we have contact force. What is this contact force that we're talking about here now? A contact force is a force that is exerted when two objects touch each other, right? As the word contact says, they need to be in contact with each other, or they need to touch each other for the force to act. So a contact force is a force that is exerted when two objects touch each other. We also have what? Non-contact force. A non-contact force is a force that is exerted over a distance. So the two objects in this one don't need to touch each other for the force to act, right? So they act over a distance, and also non-contact forces are known as field forces, right? Also, we have gravitational force. Gravitational force is a pulling force that bodies exert on each other over a distance due to their masses. We also have magnetic force, which is the force that two magnetic materials exert on each other over a distance. Then we also have what? Electrostatic force, which is the field force that arises through differences in electrical charge of objects. So now, grab this terminology so that you are able to understand as we move forward with our lesson. So now, to today's main meal, what is a force, right? We said a force is an action of pulling, pushing, or twisting, right? So a force is an action of pulling, pushing, or twisting an object, causing it to move, right? To stop or to change direction. So now, when you're applying a pushing or pulling or twisting force on an object, you either stop its movement, cause it to move, or also change the direction in which it was moving to, right? So we can define force as a pull, push, or twist action on an object, right? And in physical sciences, a force is anything that makes an object to accelerate. What does it mean? It causes it to build up speed, right? So now, when you build something, when you build up speed on something, it means you are pushing or pulling, right? When you are applying force. So now, also, if an object is stationary, it will need a force to start moving. What do we mean by that? So if an object is stationary, it is not moving, it will need some push, some pull, or some twist so that it is able to move. Let's look at these examples here, right? Let's look at these two friends here, right? This one is pushing the other one in that car, right? As he's pushing, the car builds up what? It builds up speed. This is the force applied on the car by this friend of the other friend, right? So now, he's pushing this car, and the more he pushes, the more it builds up speed. The second example here, we have friends again here. This one is pulling the other one, right, in that trolley. As he is pulling, he's applying what? Force, because it is a pulling action. As he is pulling that trolley, there's some build-up of speed. Not only building up of speed, there's some movement, right? It causes the object to move or change direction. Lastly, let's look at this bodybuilder here, right? He's picking up this big bar full of weight, right? So now he's applying two forces now in this action. He's starting off by pulling the bar, then pushes it up, right? He pulls the bar up, then he pushes it up, right? He applies two forces there, the push and the pull. But the fact of the matter is that he's applying force. He is pulling and pushing the bar. Right. So we can clearly say that forces act in pairs, or forces come in pairs, right? Meaning that there needs to be a pusher and the pushee, right? So now, When we say that forces act in pairs, it means for every action, there is a reaction. What do we mean now? When you are pushing the wall, you feel the exact same pressure pushing what? Towards you. To show that for your action, there is a reaction. You are acting in pairs with the wall, right? You are acting in pairs. As you are pushing, it pushes back to you again. Here is an example to illustrate that, right? This guy here is trying to push the wall and he's feeling what? A reaction towards his action. As he's pushing the wall pushes back to him. It applies a force on him as well. Now, how do we measure force? We said that the SI unit for measuring force is what? Is Newton, right? As abbreviated as N. It is Newton and is abbreviated as N. And we use what? A spring scale to measure force. A spring scale that looks something like this, right? It is the one that we use to measure force. So now, combining forces, right? We said that forces act in pairs. For every action, there is a reaction. So now, there becomes now what? A net force. What is this net force that I'm talking about here? A net force is the overall force acting on an object after all forces are combined, right? So sometimes there can be forces in the same direction and forces in opposite directions, right? So what do I mean by this now? Forces in the same direction, right? In order for us to find the resulting force, which is the net force, what do? We add them, right? We add them together. This is how, right? Remember, they're in the same direction. They're moving towards the same direction, right? So there is less what? There is less effort applied. So now, forces moving in the same direction, we add them, right? Here's the first force here. We are pushing what? We're pushing with 10 newtons of force. And again, what we are pushing has what? 10 newtons of force, right? So it is 10 plus 10 to give us what? 20 newtons of force. And in this case, it is 20 newtons of force to the right? And the net force, we can clearly say here, it is 20 newtons. Because now, the first object here is 10 newtons moving in the same direction as the other one, which has 10 newtons to give us a whole net force of 20 newtons. Now, I want us to look at an example of forces acting in opposite directions. Now, right. So now, when forces are acting in opposite directions, we subtract them, right? Because they are pulling away from each other. We're trying to find out what? The net force or the resultant force between the two. So as they are pulling in opposite directions, we subtract them. Here is the first force there. It has 10 newtons of force, right? To the right. Minus the one that has what? 7 newtons of force to the left, right? So what will be the resultant force here? What will be our net force? It is 10 newtons minus 7 newtons because they are acting away or they are pulling in opposite directions, right? They are moving in opposite directions. We have to subtract them. So it is 10 newtons of force minus 7 newtons of force to give us a whole net force of what? Of 3 newtons, right? Our net force here is what? It is 3 newtons of force where? To the right, right? It is 3 newtons of force to the right. Why are we saying to the right? This is because the other one which is pushing to the right has much more force than the one that is pushing to the left. So therefore, it cancels this one to give us a whole net force of 3 newtons to the right. So now, let's talk more about the forces acting in the same direction. Let's give more examples. We said that when forces are applied in the same direction, they are added to determine the size of the net force, right? So now, here are these two teenagers pushing what? This piano around, right? Probably they are moving this piano around in the house, right? The other one is pushing, and the other one is pulling on the other side. But fact of the matter is that they are going towards the same direction, right? This one is pushing, right? Pushing, this other one is pulling, right? But they're all going to the same direction, which is the right-hand side. Remember, what did we say? We said that forces, when they are in the same direction, we add them. So let's look at the forces that they exert on this piano machine here, right? The girl here has pushing force of what? 25 newtons. This girl is applying 25 newtons of pushing force to this piano here. And her brother here is pulling by 20 newtons of force to the right as well, right? They're moving towards the same direction. So how can we do this? We add the two forces applied. It is that easy, right? So it is going to be 25 newtons for the girl plus 20 newtons for the boy equals to 45 newtons of force applied on this piano machine to the right-hand side as they are moving it to the right-hand side. So the answer here is what? It is 45 newtons of net force. That is the size of the net force between the two. But remember, don't forget that when forces are in the same direction, we add them together. That's why we did what? We added this 25 newtons of force for this girl plus 20 newtons of force from the boy going in the same direction to give us what? 45 newtons of force to the right. Now, let's look at now forces acting in different directions. Different directions, we mean that they pull what? In opposite directions, right? The direction is not the same. What do? We subtract the two forces, right? So don't forget that when two forces act in opposite directions, you subtract the smaller force from the larger force to determine the net force, right? To determine the resultant force, to determine the size of the net force. So if you do that, right, the net force will be in the same direction as the larger force, right? If you do that, if you subtract the smaller force from the larger force, the direction of the net force will be of the one of the larger force, right? So now let's look at this example. We have two dogs here, right, pulling this rope. They're in the tug of war, right? They are pulling this rope in opposite directions, right? We have a bigger dog and we have a small dog, but they are both trying to win this rope over, right? This one, the small dog here, is pulling to the left-hand side, right? And this big dog here is pulling to the right-hand side. And we have the rope here in the middle, right? So now we want to determine the net force of these two, right? So what happens here? The small dog here exerts 10 newtons of force, right? It is pulling by 10 newtons of force. The bigger dog here is applying 12 newtons of force. So the forces here are not the same, right? There's the big dog and there's a small dog, right? They're trying to win this rope over. This one is pulling to the right-hand side by 12 newtons of force. So remember that we said that if forces are applied on opposite directions, what happens? We minus them, right? So we simply say 12 newtons minus 10 newtons to get what? 2 newtons of force. And where is this force going to? It is going to the right-hand side, right? Because we said that the net force will be in the same direction as the larger force. And which one is the larger force here? The larger force is this one of 12 newtons, right? It is the bigger dog with 12 newtons of force. So the resultant force is 2 newtons to the right-hand side. So meaning this big dog here is able to win this rope over to its side. Now, by that being said, it means that forces can either be balanced and unbalanced. What do we mean when talking about now balanced forces and unbalanced forces? We simply mean that when two forces that are of the same mass, the same strength, or the same forces, but acting in opposite direction, right? So now, forces occur in pairs, yes, right? and they can be either balanced or unbalanced, right? And they're acting in opposite directions. Looking at this, these two are acting in opposite directions, right? This one is pulling to the other side and this one is pulling to the other side. But notice this, there is no net force between the two. Why are we saying that? Because they are standing still, right? There is no motion. There is no movement of any of the two. Meaning what? The forces are balanced. The force on either sides are the same. But when forces are unbalanced, right, there will be some movement. There will be a net force. This one is able to pull more to its side than the other one because this one exerts a much greater force than the other one on the left-hand side, right? So meaning what? Both forces are unbalanced. Now here is an example that you are mostly related with or familiar with, right? So now, here is a group of people playing tug of war, right? Now, if you look at this, the first picture there on top, the forces on either side are balanced, right? These ones are pulling by 300 newtons, and these ones are pulling also by 300 newtons. So there is no movement between the two, right? There is no pulling on either side. It's just standing still. There is no movement because the forces on either side are the same. It is 300 newtons, 300 newtons. But notice when there is one person now on the other side, which is the right-hand side, the other person now is left off with 100 newtons of force against people of 300 newtons of force. So as they are competing against each other, the ones of 300 newtons of force are able to pull what? The other one which is left alone and having what? 100 newtons of force. They are able to pull him towards their direction. So if we were to calculate this, what would we do? We said that 300 newtons minus what? 100 newtons. It will give us 200 newtons. So meaning these ones are pulling now and having 200 newtons of force to the left-hand side. Now, moving on. Let's talk more about now balanced forces. We said that if more than one force is present, it does not have to cause an acceleration on an object. There is no movement, right? And if another force balances the first one out, there will be no acceleration at all. There will be no buildup of speed or there will be no movement at all. So remember that balanced forces as well, they refer to forces acting in opposite directions, but they have the same force applied, right? Or they have same newtons of force applied. Like here, right? These two friends are playing tug of war as well, right? They're trying to pull to opposite sides, right? So now I want you to imagine this. I want you to think if these boys are weighing the same, they pull the rope in opposite directions with an equal amount of force. How much will they move? How much will they move, right? If they're having what? Equal newtons of force and they are pulling in opposite directions. How much will they move? Zero, right? 0 newtons. They will move 0 newtons. Why? This is because the forces on either side are the same. Are we together? So now, we said that for balanced forces, they do not cause any change in motion. There is no change in motion when forces are balanced. It just stands still, right? And our net force will be what? The net force will be 0 because they are equal in size and in opposite directions. Now moving on, let's talk more about now unbalanced forces, right? But before we move on, here's an example here for balanced forces. These two guys are playing what now? Arm wrestling, right? To illustrate more balanced forces. Their newtons of force applied on each other is the same, right? So between the two of them here, there will be no movement. Yes, they are acting in opposite directions. This one is trying to win the other one over, and this one is trying to win the other one over, right? But now, because their forces applied are the same in newtons, there is no movement between their two heads. Now, unbalanced forces. We said that unbalanced forces, the forces are not the same on either side, right? So now, if the multiple forces acting at one time are not balanced or equal, then acceleration will occur. What did we mean about acceleration? We said that it is the buildup of speed, or now motion, right? If the multiple forces acting on each other are not balanced, they're going to do what? There will be some motion now, right? As you can see here, there is some motion to show that these two forces applied are not the same, right? And if one side of the scale has more mass, then gravity will accelerate it down to prove that it has more mass and more force compared to the other one on the other side. Here is a more familiar example, right? A soccer ball. As you are kicking that soccer ball, right? The force that you apply on that soccer ball is not the same as the one of the soccer ball. Hence, you are able to change its direction, and hence you are able to cause movement on the soccer ball, right? So kicking the ball causes it to move quickly in a different direction because the force that you apply on it is different than the force it has. So we said that for unbalanced forces, they always cause what? A change in motion, right? When a force is applied and it is of a greater mass or greater force than the other force, it's able to change its direction. It can stop its movement. It can also what? Change its shape, but we'll talk more about that. So now, the net force is greater than 0 because now there is what? Movement, either to the right-hand side or to the left-hand side. So when an unbalanced force acts in opposite directions, you can find the net force or the resultant force either to the right or to the left. So now here is an example here, right? This person is playing golf. As he hits the golf ball with what? With the golf stick. It causes the golf ball to move, right? To change direction even. Because now the force applied by this person is much more greater than the force that the golf ball has. Now, effects of forces. What does forces or what effect does force have on object, right? It can change the shape of an object. What do we mean by changing the shape of an object? Here is a balloon, right? It is an object. When I apply force, it can do what? It can change the shape of this balloon, right? As I apply force, it changes the shape of this balloon, right? I'm compressing this balloon. I'm pushing this balloon, right? I'm applying force and it changes the shape of the object. Not only that, forces can increase the speed of a moving object, and we therefore say what? It is acceleration, right? When you push a vehicle, when you push a bicycle, right? The more you push and the more force applied, it can increase the speed of that moving object, right? It can also decrease the speed of a moving object. So as you are pushing that bicycle and running with it, the minute you try to stop and pull towards yourself again and pull back, it starts slowing down, right? It is changing now the speed of a moving object. It is decreasing the speed of that moving object. Not only that, it can also change the direction of a moving object. Now we have Sipo kicking a soccer ball towards the soccer post, right? Trying to score, right? As he kicks the soccer ball hard, it hits the soccer post and turns towards his direction again, right? And which we call deflection. It changes what? The direction of the soccer ball. It is the force that is applied by the soccer post on the soccer ball so that it can be able to change its direction. Not only that, it can cause a stationary object to move. Hence that example of a soccer ball as well. If the soccer ball is stationary, sitting down there, when you start to kick it, it causes what? Movement for the soccer ball. When that bicycle is standing still and you start pushing it, it starts to move. Also, it can what? Can stop a moving object. Now let's move on. Types of forces, right? We have two main types of forces. Yes, all forces acting on objects can be placed what? In two broad groups, which are contact forces and non-contact forces, right? We touched a bit on contact forces. We said that contact forces are forces that require for them to touch each other for the force to act. And non-contact forces, they act over a distance. They don't need to touch each other for them to act, right? But remember the main topic for today. It is contact forces, right? So we're going to dwell more on contact forces, the one that need to touch each other for the force to act, right? So now, just to illustrate here, we have what? Contact forces. They touch each other for the force to act, to change direction, to change shape, to cause a stationary object to move. But here we have what? Non-contact, right? They do not need to touch each other so that the object can move. So now, contact forces, right? We have examples such as tension. Tension is a pull force, right? Here's an example where you have a group of friends pulling this rope. We have friction, right? Which is the force that occurs when two objects slide against each other, right? You have this car against the surface. Also, you have push force here, which is applied force. This lady trying to push the wall, right? These are two forces that are acting against each other, right? They are touching each other. It's the wall and the lady here, right? And also this person is skydiving here, right? There's some air resistance so that you can be able to float a bit, right? So because remember that air is matter. It occupies space and it has mass. So the air, it touches what? This gentleman and is able to push the gentleman up and make him to be able to float. We have also water resistant as an example. This person is swimming and the water is touching him. Remember also, water is matter, right? So they're in contact with each other, him and the water. Also here we have what? The spring force twist, right? You need to touch this metal so that you're able to twist it. It is a contact force, right? They need to touch each other. So we can define what? A contact force as a force that needs two objects to touch each other. So now, contact force, they include frictional force as well, tension force and compression force when these two bodies touch each other. Now, tension force, for example, we said that it is a pull force, right? When it pulls, they tend to stretch an object, right? They tend to stretch an object. This is why. This is because they act away from each other. Like when you are pulling an elastic band, right, from end to end, it stretches in between, right? You are applying what? Tension force because there is what? Pulling involved, and it stretches the elastic band. Same as, I love this example of tug of war, right? These two guys are trying to push the rope, to pull the rope in opposite directions, right? That as they're trying to pull the rope is stretched right here in between, right? The rope becomes stretched because now they're acting away from each other, right? Trying to pull the rope in opposite directions. The second type of contact force then is compression force. Compression force is a push force, right? This one tends to compress, squash, or flatten an object because now they act towards each other, right? Now, look at this. This person is trying to compress this object, right? To push and act what? Towards the two surfaces, right? Towards the two forces. So now, the same example as you are trying to squeeze the juice out of your orange, right? You are compressing it, you are squashing it, or you are flattening it. You are applying what? Compression force to the orange. The last one that we are going to engage on is frictional force. And I said that frictional force is when two objects slide against each other, right? So it refers to the force generated by two surfaces that contact and slide against each other, right? So here's an example here. Probably you're doing your spring cleaning at home. You're pushing the sofa around the dining room. What happens? You hear that squeaky sound, right? Where does that squeaky sound come from? It comes from the force that is exerted by the sofa and the surface. And just between the sofa and the surface, where the sound comes from, that's where you find your force of friction, or rather, frictional force. Also, when you kick the soccer ball, as it runs down on the surface, right, it forms what? A force of friction between the soccer ball and the surface. Hence, it scratches down here, right? It forms a force of friction between the soccer ball and the surface, probably your grass, your tar, or the soil, right? Now, there are certain factors that affect frictional force. I want us to explore them, right? Now, these factors are mainly affected by the surface texture, how smooth or rough the surface is. It affects the amount of friction, right? It is the surface texture and amount of force impelling them together. Not only that, the angle and position of the object can affect the amount of frictional force, meaning the position in which you put the object, right? It can affect what? The rate of friction or the frictional force between the two objects. Thirdly, if an object is placed flat against an object, then the frictional force will be equal to the weight of the object. And lastly, if an object is pushed against the surface, then the frictional force will be increased and becomes more than the weight of the object, right? Here are the same examples that we're using here, right? Pushing the sofa in the house and also soccer ball, right? So the position in which, or the angle in which you kick the soccer ball, it affects the rate of friction between the soccer ball and the surface. Also here, the amount of force impelled on the sofa as you are sliding it in the surface or on the surface. It affects the amount of frictional force between the surface and the sofa. So now, let's test ourselves using this activity. Then after that, you can meet again after 2 minutes. But first of all, let's read through the questions. It says, study the diagram below and answer the questions that follow. So we have a lady here pushing the trolley. And number 1 says, identify the type of force the woman is exerting on the trolley. Then 1.2, it says, what effect does a woman's force have on the trolley? So now take your 2 minutes, answer these questions. We'll meet again after that. Welcome back, grade learners. Now, I hope you were able to answer our questions, right? So now, number 1.1, identify the type of force the woman is exerting on the trolley. What type of force is that, right? It is a contact force, right? Because she needs to be in contact with the trolley to be able to push it. She needs to touch the trolley to be able to push it. 1.2, what effect does the woman have on the trolley? It causes the what? It causes the trolley to move. Now, just take a minute to copy down the corrections so that we can be able to continue. Welcome back, grade 9 learners. Now, I hope you are done copying down the corrections and you now understand the types of forces. Now, this slide is specifically for you, right? It's for us to engage with each other, right? Remember, our WhatsApp interactive number is 079-578-2908. So now, let's give you about 4 minutes so that you are able to ask us any question or comment on the lesson. Take 4 minutes. We'll give you 4 minutes so that you can be able to answer us or comment, right? Just 4 minutes.
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful. Ubonge, lebuha. Be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Welcome back, grade 9 learners. Now we have a question from a learner from Laban Mutlabi Comprehensive School. They are asking how to calculate for force, right? So the formula is force is equals to mass of an object multiplied by acceleration, right? That's the formula that we use to calculate for force. But topics like this, we deal with them in later grades as grade 10, right? We have mass multiplied by acceleration. So you check them, mass of an object multiplied by the acceleration to get the amount of force. So now, let's summarize what we have learned for today. Today we talked about force, right? We said a force is an action of pulling, pushing, or twisting an object, right? So as you pull, push, or twist, it causes the object to move. It causes the object to build up speed. It causes the object to change shape, to stop a moving object, and so on, right? So now, we said it's an action of pulling, pushing, or twisting, right? And we said that force is measured in units called newtons and abbreviated as N. Not only that, we talked about forces that two objects exert on each other. They always act in pairs, right? We said that for every action, there is a reaction. Forces act in pairs. So you still remember our example of you trying to push the wall. As you're trying to push the wall exerts some pressure back to you again, right? So they act in pairs. Not only that, we talked about the fact that a force can change the shape, direction, and speed of a moving object, right? And also, all forces acting on objects can be placed in two broad groups, which are field forces, which are your non-contact forces, and also what? Contact forces. So the two main groups are what? Contact forces and non-contact forces, right? So we dwelled more on the types of contact forces today, right? We said that we have tension force, where it is a pull force that tends to stretch the object because they act away from each other. We talked about frictional force, the one that acts when two objects touch and slide against each other. We talked about what? Pushing force, right? To say that they act in pairs as you push the object. As the lady here trying to push this wall, it is exerting a force on her as well. And air resistance being an example of contact force, because as this person is skydiving, there is air, an air which is matter, it occupies space and has mass, so it is acting against this person here, right, to apply force on him. And also this person swimming here is an example of a contact force, because he is in contact with the water, and the water is offering some resistance to him as well. And the spring force twist, where you have to touch this metal to be able to twist and open it. So now, I hope you have enjoyed today's lesson. Let's meet again on another lesson when we're talking about non-contact forces. Remember, non-contact forces, they act away from each other. They act over a distance, right? They don't need to touch each other for the force to act. So I hope you come ready. From me to you now, thank you and goodbye.